Hey, here we go. So in this video, we're going to be using the zero product property to solve a quadratic equation. Let's get started right away by talking about what is the zero product property so that we can begin. First thing you need to realize is what the zero product property is. That is just A times B equals 0. The zero product property states that if you have one term times another term and your product is a 0, you know that either the A or the B is a value of 0. One of the two has to be 0 to make this true. So let's just pick a random number for the other one. Let's say A is 9. So it'd have to be 9 times a 0 in order to get 0. Or if we were to flip it, let's say the B is a 9, then that means the A would have to be a 0. Zero product property states that if our product is 0, one of the two terms has to be a 0. Why do we need to know that? I will show you. So one thing we know is that when we are trying to solve a quadratic equation, we always want to place it equal to 0. Okay? So you see that I just underlined that there. We're saying all of this quadratic equation is equal to 0. Now you on the other end might be saying that's not a quadratic equation. Yes, it is. It's just been factored already. So let's do a quick rundown of what we're talking about right here. We've been dealing with ax squared plus bx plus c. You normally see a quadratic equation written out like that, but when we factor that, we always end up getting two binomials being multiplied by each other. So in this video, that step isn't being shown. It's just starting at the factored form. And we already have that factored form here with 4k plus 3 times k plus 7. So it's taking what was originally a quadratic the way we see it in our standard form and factoring it out into two binomials. Now that we've done that, we're able to solve. And I will start by starting with the zero product rule. Zero product rule states that this is either a 0 or this is a 0. And when I say this and this, I'm talking this binomial has to equal 0 or this binomial has to equal 0. So the information inside should add or total to a 0. So the way to solve one of these is just simply by writing out two equations. For the first one, say 4k plus 3 equals 0. For the second binomial, say k plus 7 equals 0. As long as one of those is a 0, we know we will get a product of 0 at the end. So let's just figure out which. We'll solve each one of them and we'll get our two possibilities. So for this first one, it's a two-step equation. We're going to subtract 3, cancels, subtract 3. Now I have 4k equals negative 3. Divide by 4, cancels, divide by 4. And my final result is k equals negative 3/4. That is one of my solutions. My other solution comes from solving this one-step equation right here. Opposite of adding 7 is subtracting 7. Cancels out. And I get k equals negative 7. So these are my two solutions. If I wanted to write them as ordered pairs, it would just simply be negative 3/4, 0 and negative 7, 0. We know that these are the 2 points that would cross the x-axis. Those are our solutions to the quadratic. All right, let's move on to another example. Here I have x minus 6 times x minus 8. Again, two binomials being multiplied by each other, which originally would have been factored from an ax squared plus bx plus c. Now in my future video, you're going to get the quadratic written out like this. Step 1 is going to be factoring it into what we see here. So this video is just basically showing you the last and final steps to a full solving of a quadratic, just so we can get the hang of that before we have to do factoring as well. All right, so x minus 6 times x minus 8. We can solve these ones pretty quickly. Remember, we need to know that that's a 0 or this information is a 0. So we're going to say x minus 6 equals 0 and x minus 8 equals 0. One of those two has to be true to get the product of 0 here. Solve each one of them. We're going to add 6, cancels, add 6, x equals 6, add 8, cancels, add 8. We're going to get x equals 8. So our two solutions are x equals 8 and x equals 6. So that would give me 6, 0, and 8, 0 as my 2 points where my parabola would cross the x-axis. Okay, hopefully this makes sense to you all, and good luck.